Okay, so there's my attempt at the renegade. Okay, so we are back. This is Packet 1, and we are doing problems 12 through 22 today. So remember, pause this video at any time that you need to slow things down or write things down. And let's go ahead and get started. Okay, so it says a cylinder, which is what this is. A cylinder is also like a can. Okay, a cylinder is sliced vertically as shown. What shape is created by the cross-section? Well, if you can see how this one is split down the middle, if you opened it up, what you would actually see is a rectangle. If you sliced a can in half and you unfolded it, it would look like a rectangle. So our answer is rectangle. And that's if you were like super precise, by the way. Some of you are going to try and cut a can open and it's going to be all wonky. So don't try that at home. You also might cut yourself, so let's not do that. Okay, let me move me out of the way. All right, it says Kyle has a bag that contains 5 blue marbles, 4 red marbles, 2 green marbles, and 1 black marble. Without replacement, he pulls 2 marbles. He pulls out 2 marbles. What is the probability he will pull out a blue marble first and then a green marble? Okay, well, we need to first see how many blue marbles there are. That's 5. Okay, so there are 5 blue marbles. Blue. Out of how many total? Our bottom number is always going to be the total. Okay, and if we count it up, 5 plus 4 plus 2 plus 1, so that's 9, 10, 11, 12. We got 12 as our total number. We're going to multiply that by, let's pretend we took 1 out. Okay, now we have 1 less, so our bottom number is now 11 total. Okay, and we have 2 green marbles, so our green goes on top. And then you're just multiplying straight across, so 5 times 2 gives us 10. I always never leave enough room here. I don't know why I do that to myself. And then 12 times 11 gives us 132. I'm going to rewrite that over here. Okay, so our probability really is 10 over 132. Now, this is not reduced form, so you can divide both of these by 2 because they are both even numbers. And 10 divided by 2 gives us 5, and 132 divided by 2 gives us 66. So your answer could be the probability is 5 out of 66 chances. Or you could divide the top by bottom number. You would get a really long decimal, but you could turn it into a percent, and it would be about 7.6%. I think either answer here would be acceptable, but because this one is not rounded, this may be a more accurate representation. Okay, number 14. The PE department has a basket of tennis balls. The balls are 6 green, can't read, 4 blue, 5 yellow, and 2 purple. The teacher removes 3 balls from the basket without replacement. So if you are replacing it, okay, like in the last problem, for example, if you saw how we went from 12 total to 11, that was because we did not replace it. If you did replace that first marble, then you would keep this as a 12. If you put that marble that you just took out back in there and then did the probability of the second marble, you would leave that bottom number the same. But because for this one and the next one, we are not replacing it, then our total numbers would be different. The second total would be 1 less than the first. Okay, sorry. Back to what we were talking about. Okay, so the teacher removed 3 balls from the basket without replacement. Select each of the following outcomes that could represent the selection. Okay, so there are exactly 3 tennis balls. That is true. We could pull out exactly 3 green tennis balls. That could be an option. It's not saying that that is exactly what you're going to do. It's saying, is that a probability? Or is that a possibility? Yes. B says there are more purple tennis balls than other colors. Well, if you pulled out 2 purple tennis balls and then a blue one, okay, yes, you would have more purple than blue. So is that a possibility? Yes, that is a possibility. Okay, C says all of the tennis balls are green. Again, I think this is the same as the first one. So the answer to that is yes. You could pull out all where all the balls are green. Okay, so all 3 of the balls that you pull out, they could be green. Okay, D says the number of purple tennis balls is the same as the number of yellow tennis balls. That is not true because oh man, I hate when I do this with the eraser. Okay, sorry. This is not true because we have an odd number of balls that we're pulling out, right? We're only pulling out 3. So we cannot have the same number of purple tennis balls as yellow tennis balls. I think for this one, it is actually talking about the balls that are represented inside the basket. So the number of yellow is not the same as the number of purple. And then E says there is 1 tennis ball of each color, which is not true. You could, if you're pulling 3 balls out of the basket, you could not pull out 1 of each color because there are 4 colors and only 3 balls that you're pulling out. Okay? That one was kind of tricky. Okay, so let's move on to the next one. I'm not 1,000% sure about D. We should talk about that one some more. I just think the way it's worded is a little bit confusing. Okay, so moving on. Number 15, on the coordinate grid below, draw a quadrilateral, that is a 4-sided figure with 2 lines of symmetry. Remember, a line of symmetry is, for example, if we, on FSA, they do oftentimes letters. Okay, so if we were doing the letter A, and if I wrote it correctly, okay, this would be a line of symmetry straight down the middle of A. And again, if I could draw a straight line, that would be helpful, right? A line of symmetry is if you folded it on that line, if this half looked exactly like this half, then that is a line of symmetry. Notice that if we folded it this way, the top half would not look like the bottom half. So this is not a line of symmetry, but this is a line of symmetry. Does that make sense? Okay, so now we want to draw a quadrilateral with 2 lines of symmetry. Okay, and that would be a rectangle. So it does not matter how big or small your rectangle is. Okay, so there's our rectangle, and I am going to show you the 2 lines of symmetry. I should have done this exact number, 1, 2, 3, 6, 7, 8, 9, 10, 11. Of course I didn't do it an exact number. Okay, so 1, 2, 3, 4, 5.5. We're going to draw our line of symmetry straight down the middle. I can't draw a straight line anyways. Who am I kidding? Okay, so there's our line of symmetry there, and our other line of symmetry is horizontal, and it goes this way. Okay, so that has 2 lines of symmetry, and it is a rectangle. Okay. Okay, a number line is shown below. Plot a point that is 7.5 units from 6 on the number line. So we're just going to move over to the left, 7.5. 1, 2, 3, 4, 5, 6, 7. And then we have a half right here. Okay, and that is at negative 1.5. Okay, so it says, what is the value of the expression below? We have a negative and we are adding a positive to it. You guys were taught a song, or most of you were. Same signs, keep and add, different signs, subtract. Keep the sign of the greater number, which is actually the greater absolute value, and then you'll be exact. Okay, so obviously my singing skills are terrible, but let's put negative 3.5 on top. Okay, and then we were adding 6.25 on the bottom. First, before you do anything else, we have to get a common denominator here. And our common denominator is going to be 4 because 2 can go into 4 and this is already in fourths. So 6.25 can stay the same. And to change this 2 to a 4, we would just multiply it by 2. 2 times 2 gives us 4. Whatever you do on the bottom, we have to do to the top. So if you multiply by 2 on the bottom, you have to multiply the numerator by 2. 1 times 2 gives us 2. And do not forget your whole number, which is negative 3 out in front. Okay, so now we have negative 3.25 plus 6.25. But remember, different signs subtract. Okay, so we are actually subtracting these two. So I'm going to actually come down here. So I'm going to put 6.25 on the top, and I'm going to subtract 3 2/4 from that number. Right now, we cannot take 2 from 1. So in order to do this, we have to borrow from the 6. The whole number 6 now becomes a 5. And then to change this numerator, we are giving it 1 whole. And in fourths, that's 4/4. So we are adding 4 to that 1. And now this is 5/4. So 5 5/4 minus 3 2/4. 5 minus 2 gives us 3. Our denominator does not change. And then 5 minus 3 gives us 2. 2 3/4. If there's an easier way for you to get this answer, go for it. I know this is multiple steps and definitely more time consuming, but that is the correct answer. If you wanted to write it as a decimal, you absolutely could do that. It would be 2 75/100. So 2 3/4 or 2 75/100. And the reason it is positive is because our 6 has the greater absolute value. So we are giving our answer that same value. Okay, and it makes sense, right? Because if you are at negative 3 1/2 and you are adding 6, you are going this direction. Okay, so that's like this is 0. Okay, and so it would make sense that your answer would be a positive. Nope, that's a 3/4. A positive answer. Okay, so negative 3 1/2 plus 6 1/4 gives you 2 3/4. Okay, a pyramid is sliced horizontally as shown below. What shape represents the two-dimensional cross-section of the pyramid? Remember, a cross-section is just when you slice that and you open it up. That's a cross-section. If you open it up, it's asking you what shape, why do I always do that? What shape you are going to see. Okay, so if you notice, okay, you are going to see a square because the bottom of this square pyramid is a square. Now, if you sliced it vertically like this, straight down the middle like that, it would be a triangle. It would be in the shape of a triangle. But because we are slicing it horizontally, it's going to be whatever the base is, which in this case would be a square for square pyramid. Okay, now this is very similar to what we did in number 17, except for now we're using decimals instead of fractions. Again, same signs, keep and add, different signs, subtract. Keep the sign of the greater absolute value, and then you'll be exact. Okay, so we are actually subtracting these two numbers. Remember to line up your decimals. Line them up. We had to annex a 0 here. We cannot take 5 from 0, so we will have to borrow. And 10 minus 5 gives us 5. 2 minus 2 gives us 0. 2 minus 2 again gives us 0. And 2 minus 1 is 1. So our answer here is, sorry, my dog was barking. Okay, so our answer is 10 5/100. Also, they're going to be giving you these questions on the day of FSA that you are not allowed to use a calculator, most likely. So this one and then the fraction one that you did previously, those will probably be the days that you will not be able to use a calculator. So I would suggest doing this the old-fashioned way instead of putting it into your calculator because you need to know how to do this the old-fashioned way. With pencil and paper, I guess I should say. Okay, number 20. A potato chip company randomly selects 25 bags of chips and records the weight of each bag. Bags of chips also. I really think that they do not put enough chips in the bag. Like you open up the bag and there's only like 3 chips in there. Sorry, I digress. Okay, so 25 bags of chips and they are actually recording the weights. Okay, so 5 of the bags have an incorrect weight. I think it's more like 25 out of the 25, but whatever. Okay, so 5 of the 25 bags, this is incorrect. 5 of them are incorrect. Okay, out of 25 total. How many bags of chips should the company expect to have incorrect out of 1,000 bags? So, 1,000 bags. We want to know how many are incorrect. Okay, and the way you do this one is you're cross multiplying and dividing by that other number. So 5 times 1,000 gives us 5,000. I need a spot to do this, don't I? Okay, so 5,000. And then we are dividing that number by 25. 25 cannot go into 5, but it can go into 50 2 times. 2 times 25 is 50. Subtract and we get 0. Bring down our 0. 25 goes into 0 0 times. Bring down our other 0. 25 goes into 0, again 0 times. So our answer is 200 of the bags will have an incorrect weight. Okay, the double box plot below represent data for the overall grades of 2 math classes. What is the difference in the median between the 2 sets of data? Remember, if we're looking at a box plot, the median is that line. It doesn't have to go down the direct center of your data, because even though you can't tell, each of these represents 25% of your data. It just doesn't look that way. So all of these parts are broken up into 25%, and 25% plus 25% is 50%. So our median is always representing 50% of your data. It's directly in the middle. Okay, so it wants to know the difference between these two. When we see this word difference, it means to subtract. Okay, so here we've got 75 and here we've got 80. So all we're doing is subtracting 80 minus 75. Our answer is 5. That was simple. Okay, last one. Yay! The number of cans of food brought in by students in 2 different classes at Oakwood Middle School is recorded in the dot plots below by their teachers. Mrs. Mitchell added another student's can donation to make the median the same as Mrs. Phillips' class median. Place a dot where it could be located in Mrs. Mitchell's dot plot to show the addition. So we've got, for Miss Phillips' class, I'm actually going to write out all of the numbers. So we've got 0, 1, 2 2s, 3 3s, 4 4s, 2 5s, 2 6s, and a 7. Okay, to find the median, all we're doing is we're crossing off 1 from either end until we get to the middle number. And if there are 2 middle numbers, we are going to add them together and then divide by 2. Okay, so if you count, you should have an equal number on the left as you do the right. So 1, 2, 3, 4, 5, 6, 7. And we have 1, 2, 3, 4, 5, 6, 7. So we have the same number on the left as we do on the right, which is good. We do still have 2 numbers in the middle. So to find our median, we add those 2 numbers together, which is 8, right? And then we divide that number by 2. So 8 divided by 2 does give us 4. So the median for Mrs. Phillips is 4. Now to find Mrs. Mitchell's median. So we've got, let's do hers in blue so we don't get confused. We've got 0, 2 1s, 2 2s, 3 3s, 2 4s, 2 5s, 3 6s, and a 7. Okay, so again, I'm going to do the same here so we can find out what our median is so that we know what number we'll need to add in order to make the median the same as Mrs. Phillips' class. So, count off 1 from either end. 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. So we have 7 on each side. So we would add these up and divide by 2, right? So 3 plus 4 gives us 7, and 7 divided by 2 gives us 3.5. We want it to be bigger than 3.5. We actually want it to be 4. So the number that I would add in here, okay, would be a 4. Because if you added 4 in between these two, you could cross off the 3 and the 4, and then our middle number would be 4. So we would place our dot here to make them have the same median. Okay, that's all I have for you guys today. We still miss you guys a bunch. We hope you guys are doing super awesome at home. Please email us or write us on Teams if you have absolutely any questions, and we'll see you later.